Hi friends, good morning and welcome to this class again. Hope you are all keeping fine, busy studying your lessons. So we are studying these days about minerals, and yesterday we saw ferrous minerals and non-ferrous minerals that all come under the category of metallic minerals. Both contain metals. Then today let us see about non-metallic minerals, that is minerals that do not contain metals. There are so many minerals are there where there are no metals in them. So let us see about them. And the first one is mica. Mica. So mica is a mineral made up of a series of plates of or leaves. So how this mica is made? It is made up of a series of plates. So it is a layer, one on top of the other and kept. That is called mica. And it splits easily into thin sheets. So since it is made of different layers, we can split them into very thin sheets. And these sheets can be so thin that 1,000 can be layered into a mica sheet of few centimeters high. Mica can be clear, black, green, red, yellow or brown and so on. Since we said it is laid by layer and it is very small layer, very thin layer, and therefore within a few centimeters we can keep them thousands of pieces. 1,000 of pieces can be put together and it will come only this much even after putting 1,000 pieces. That means it is so thin, much thinner than your paper. You can imagine if you put 1,000 papers together in your notebook. Your notebook may have how many pages? May have hardly 60 or 70 papers, isn't it? Then it becomes this much thick, isn't it? Just imagine if you are putting 1,000 pieces of paper, how thick it will become? It may become very thick, no? But here mica, even if you put 1,000 pieces, it becomes only just a few centimeters. That shows it is much thinner than the paper. So you can imagine how thin it will be. Then mica can be of different colors. Sometimes it can be of clear color, sometimes it can be black or green or red, yellow or brown. Different colors it is available. Then due to its excellent dielectric strength, low power loss factor, insulating properties and resistance to high voltage, mica is one of the most indispensable minerals used in electric and electronic industries. So mica has got very special qualities. First of all, it is dielectric. Dielectric means, the other day when we are studying about aluminum and copper, we said they are conductors because they allow the electricity to pass through. So dielectric means not allowing the electricity to pass, that is non-conductor. So it is just opposite of copper and silver. This mica will not allow the electricity to pass through. So because of that, it is used for insulating. So and other qualities are, it has got very low power loss. If you use this one for protecting the wire, then the power loss is not there. Suppose the electric wire that is naked without any cover, lot of electricity is lost, and so in the internal wiring we use the wire which is covered with plastic cover, so that the loss of power will be less. So if you cover with this mica, then the power loss will be very less, because mica has got that power, that capacity to reduce the loss of electricity. Then it is also has got insulating capacity. Since it is not allowing the electricity to pass through, it is used for insulation. Insulation means covering, for covering the wire. Insulation, mica is used. And so because of these qualities, it is very much used in electrical industry as well as in electronic industry. and also it has got another quality to resist high voltage. Usually if the high voltage is passing through, the metal will start melting. Some wires, short wires, small wires, we can see if it is connected to heater, and so the wire will start smoking or melting because it cannot control the high voltage. But even if a wire has got a high voltage and if it is covered with mica, then it will not melt because it has got that capacity to resist against high voltage. And so because of this, it is used in two industries. Which are the two industries where mica is extensively used? Electrical as well as electronics. Then mica deposits are found in the northern edge of Chota Nagpur Plateau. You can underline. Where do you find mica deposits? It is found in Chota Nagpur Plate, where the northern edge of the Chota Nagpur Plate. And Koderma Gaya or Hazarigunj belt of Jharkhand is leading producer. So the Jharkhand, there is a mica belt is there, which is between two places, that is Koderma Gaya and Hazaribagh. Between these two places, the mica deposits are there. And in Rajasthan, the major mica producing area is around Ajmer. And Nellore mica belt of Andhra Pradesh is also an important producer in the country. So apart from Jharkhand, there are other two states which are producing mica. One is Andhra Pradesh, another one is Rajasthan. These are the three states: Andhra Pradesh, Rajasthan and Jharkhand. These are the three states which are producing a lot of mica. Then another one is called rock minerals. The minerals that are found in rock. So first one is limestone. You know limestone, which is used for the chalk that we are writing. All that is made of lime. And the paint that we use for whitewashing the wall, the white one, that is also coming from this limestone. So limestone is found in association with rocks composed of calcium carbonates or calcium and magnesium carbonates. It is found in sedimentary rocks of most geological formations. Limestone is the basic raw material for the cement industry and essential for smelting iron ore and blast furnace. So what is the purpose of this limestone? So it is found in the rocks composed of calcium carbonates or calcium and magnesium carbonates. That are the components or parts of this limestone. Then it is found in sedimentary rocks of most geological formation. So wherever these sedimentary rocks are there this limestone also is found. Then limestone is the basic raw material for the cement industry. You can underline. So the most important use of limestone is to manufacture cement and essential for smelting iron ore. So when they make iron ore, they have to boil it. Generally it will be separated. The iron ore will be separated from other ores that are mixed in it. So to melt it, we need high temperature. So this limestone is used for melting them. And also it is used in the blast furnace where this iron is melted. So that is one of the purpose. Then let's see a footnote given there. Hazards of mining. Hazards means dangerous. So we speak about we have mine deposits and so on. But this mining process is very dangerous. It is very risky, and that's what we are saying. So have you ever wondered about the efforts of miners making life comfortable for you? So many things that we use made of metals and other minerals, and we never think how this has reached the present form. So people who are working behind, we never think about the hardship that they are undergoing, the trouble that they are undergoing, and so on. Then, what are the impacts of mining, the health of the miners, and environment? So people who are working in these mines, what do you think about their health? Because it is very dangerous inside. Sometimes it can burn, sometimes the mud can fall down and they can die inside, or sometimes it can catch fire. So a lot of risk is there, and so their life is really in danger. And the dust and the noxious fumes inhaled by miners make them vulnerable to pulmonary diseases. So inside these mines there will be plenty of noxious. Noxious means a harmful fumes. Fumes means the fires, the spark, and so on. And the dust, lot of dust also will be there. So they are breathing all this dust and this poisonous gas, then it can affect them pulmonary disease. Pulmonary means lungs, because they are breathing this polluted air which is having a lot of poisonous gas as well as the dust. Their lungs can be affected. The risk of collapsing mine roofs, inundation, and fires in coal mines are a constant threat to miners. So, there is a risk of collapsing mine roofs. They are making hole and entering inside, and especially in the raining season, and so the mine mud can collapse and they will be trapped inside. Then there can be inundation. So sometimes the river water enters into it from under the earth. Water, if they are digging and going, sometimes suddenly they will find a water source. Then suddenly water will rush in and they will be in danger. Or sometimes fire can catch and so on. So all these are very dangerous situation for the people who are working in the mines. Then the water sources in the region get contaminated due to mining. So when we do this mining, the water in that area that gets contaminated. These elements of the minerals get into the water source. So dumping of waste and slurry leads to degradation of land, soil, and increase in stream and river pollution. So it can cause a lot of environment pollution. For example, we said water source can be polluted, the land can be degraded because a lot of dust and waste will be there when they do the mining. All that will be thrown here and there, and the environment gets polluted, the air gets polluted because all this dust will enter into the air, atmosphere, and so on. Therefore, it is quite dangerous to have a mine nearby, and the health of the miners are also affected because of their dangerous working conditions. Quite many people, especially the young children who are working in this mine, their life have been lost. Quite many of them have got sick and died. Some of them get accident and die, and so on. Then stricter safety regulations and implementation of environmental laws are essential to prevent mining from becoming a killer industry. So this mining, another name for mining industry is called killer industry, because it kills so many people who are working there, people who are living in the nearby places. They are all affected with different kinds of sicknesses, especially lung diseases, and this industry is killing so many people. So what we need to do, we have to make safety regulation, we have to make the safety conditions very strict, and implementation of environmental laws. We have to make sure that these industries are following this environmental laws. They cannot just do the mining and take the thing and go, but they have to follow the law and they have to follow up the conditions, all that. Then only the mining industry will become a safe industry. Otherwise, it will continue to be a killing industry. So we can see a lot of newspaper clippings are given there. You can just read and see how the people were affected and so on the danger that is there also. Then these are the minerals that we see. Now let us come to another topic, that is conservation. How do we do conservation? I hope you know the meaning conservation. We have studied several times in the previous classes and the previous years. So the conservation of minerals. We all appreciate the strong dependence of industry and agriculture upon mineral deposits and the substances manufactured from them. So we said in the beginning of this lesson that everything that we use, starting from a small needle to the big machines that we use in our daily life, everything is coming from minerals, and therefore we appreciate the presence of minerals, the deposit of minerals in our country, because if these are not there, then our life will be like a primitive, where the people were using stones and sticks and all to attack, to hunt and so on. Now we have modern weapons, and so everything is made of metals. And so the total volume of workable mineral deposits is an insignificant fraction, that is 1% of the earth's crust. So the minerals that are found on this earth is just 1% of the earth. So there is not much deposit, that's 1%. That's what the whole world is using. And we are rapidly consuming mineral resources that required millions of years to be created and concentrated. So we are using very lavishly, we are making so many things with minerals which are formed after thousands or millions of years. These minerals are formed not with after few years or so. It took millions of years to be formed inside the earth. And the geological processes of mineral formation are so slow that the rates of replenishment are infinitely small in comparison to the present rates of consumption. And mineral resources are therefore finite and non-renewable. And rich mineral deposits are our country's extremely valuable but short-lived possessions. So the minerals, they can get over because it is very little only, just 1% of the earth, and it is being formed after millions of years. Therefore the way that we are using so much, and the formation is so slow. Therefore, if you go on at this rate of consuming these minerals, using these minerals, what will happen? After some time, there will be no more minerals available for the future generation. They will have to continue to go back to continue to live like the primitive stage without using much minerals. So that is a problem. We need to be concerned about our future generation, and we have to do something in order to help them. Then minerals, most of them are finite. Finite means not lasting forever. It will get over after some time, and it is non-renewable. It cannot be renewed again. Once we use, it is finished. Then rich mineral deposits are our country's extremely valuable but short-lived possessions. So the minerals that we have in our country, that is our precious possessions. If that is not there, we become much more poor, and we can say we will become poor. And these possessions that we have, these minerals that we have, they are short-lived because they are finite. They cannot last forever. The more we use, the faster it will get over. Then continued extractions of ores lead to increasing costs as mineral extraction comes from greater depths along with decrease in quality. So the more we take it out, what happens? It becomes less important in quality. It will become less quality. filled with having less quality minerals. So we need to keep them for getting matured. As soon as it is formed, if we take it out, the quality will be less. So the older, the greater will be the quality. Then a concerted effort to be made in order to use our mineral resources in a planned and sustainable manner. Improved technologies need to be constantly evolved to allow use of low-grade ores at low cost. Recycling of metals using scrap metals and other substitutes are steps in conserving our mineral resources for the future. So how can we do the conservation? How can we preserve? How can we preserve the minerals? What are the steps? So some of the methods are improved technologies. So we need to use modern technology. If we use the old technology, it is consuming more and need to be constantly evolved. So as soon as our machine is old, we need to renew it. We need to make it new or get better one. And the use of low grade ores at low cost. So we need to, if we have that improved technology, what is the advantage? It will allow us to use low grade ores. We can use even the ore that is low grade, and we will be able to use it with a low cost. And recycling of metals, another thing is recycling. If something getting spoiled, we don't have to go and throw away into the river or into the drain, but recycling. Many people will come around asking for buying old iron, and so the tins, the bottles, the plastics, all these are recyclable. Try to sell it to them and get the money, and with that money we can do something. Instead of wasting these things there and polluting the atmosphere, we can sell it away for recycling. And using scrap metals. So scrap means small. So small metals that we can use, and other substitutes are the steps in the minerals. So what are the steps? We can improve the technology. Second one is we can do the recycling. Then using scrap metals. Then use the substitutes other minerals which can be used as a substitute. These are the methods by which we can save our environment and save our minerals as well. Then let's see about energy resources. Another topic is energy resources. So long we are talking about minerals, and the third type of mineral is energy resources or energy minerals. So energy is required for all activities. So we also need energy. That's why we are eating food, in order to get energy for our body. And it is indeed to cook and to provide light and heat, to propel vehicles and to drive machinery in industries. So apart from providing energy to the human beings and other living beings, it is also used for cooking food. We cook food with using energy like LPG gas, firewood and so on. Then it provides light and heat. So we get electricity, that is energy, to burn the light and also to use heater and so on. Then to propel vehicles. Propel means moving. The vehicles are moving because the engine is running, and for that engine to run we need energy, oil, petrol or diesel, and so is used. Then and to drive machinery in industries, and in the industry there are so many machines are there, so many instruments are there, all that are functioning because of energy, maybe electricity. So energy is required for in every field, in every area to complete our work. Then energy can be generated from fuel minerals like coal, petroleum, natural gas, uranium, and from electricity. So which are the sources of power or energy? It is from, we can get it from petroleum, from coal, from natural gas, from uranium, and from electricity. These are the sources of energy. Then energy resources can be classified as conventional and non-conventional sources. We can underline. Energy sources can be divided into two types. One is conventional, another one is non-conventional. Let us see what is conventional. Conventional sources include firewood, cattle dung cake, coal, petroleum, natural gas, and electricity. So we can underline these are conventional sources of energy. So by looking at what do you understand? They are the common sources of energy which people use for a long time. For example, firewood. People have been using firewood from long time onwards. Then some people use cattle dung cake, like cow dung and so. They will take it and keep in the sunlight, make it dry, then they will use it for burning. So people where they are living dry places, near to desert area and so, there is no tree at all for them to cut firewood. So what they do is they collect powder, make it dry and use for burning. So that is another source of common source of energy. Then coal, they dig out the coal and use it for burning. Then also petroleum and diesel, all those things we are using very commonly. Then natural gas, LPG, that also we are using. Then electricity also we are using. So there are two types of electricity, or two ways of production of electricity. One is from hydel, that is water. Another one is thermal. There are two type of thermal, means heat, from the heat of the earth. Under the earth we know it is burning inside. So that heat comes out sometimes through the cracks and so on. Then that can be made use for producing electricity. Then non-conventional sources include solar, wind, tidal, geothermal, biogas and atomic energy. So these are the sources of energy which cannot be used by common person, or which cannot be produced easily. We need a lot of technologies in order to produce this conventional, non-conventional source of energy. Which are they? They are solar. So ordinary person cannot go and use solar energy. We need high technology, we need the solar panel, we need to convert that solar energy into electricity. So we need inverter, all those things. So it is not used very commonly. Then wind energy. We know some places wind is very strong. So to collect that energy from the wind, we need the windmills, we need the machines, technology and so on. So that is not used very commonly by the people. Then tidal energy. Tidal means high tide and low tide, we know, from the sea. So we fix a machine there. When there is high tide, water will be coming up and the turbine will be running and we can make electricity. In the same way, when there is low tide, the water will be going down and again the turbine will be running, so will produce electricity. So all that is not easy for a common people. Then geothermal, the thermal energy that is coming from under the earth. We said electricity can be produced not only by hydro but also thermal. And biogas, another one is biogas. That is somewhat easy to make it, but for every family it is not very easy. So that is by putting the waste, cow dung and all those things and make it process, and it will start producing gas. So it has to be kept in a tank and closed very tight, and then it will start producing gas, and that gas can be used for cooking and so on. Then atomic energy, another one is atomic energy. That is again the ordinary people cannot do. We need scientists and so these are the sources of energy which cannot be used by a common person without the high technology. So that's why they are called non-conventional source of energy. So an ordinary person is not using these sources of energy regularly or daily. So what he is using is petroleum products, firewood, cow dung cake, gas, electricity, and so all these are common in every house. But wind energy, solar energy, hydroelectric, the thermal energy, tidal energy, all these are not very common. People cannot use very easily. Then the firewood and cattle dung cake are most common in rural India. You can underline. In the rural India, the people what they use more commonly is the firewood and the cow dung cake. And according to one estimate, more than 70% energy requirement in rural households is met by these two. The continuation of these is increasingly becoming difficult due to decreasing forest areas. So in the rural area, the people almost 70% of their energy is met by these two sources, firewood and cow dung cakes. And now it is becoming less and less difficult because people are cutting and cutting, the forest is getting over, no more trees are there to make firewood, therefore people are finding difficult to get firewood. And moreover, using during dung cake too is being discouraged because it consumes most valuable manure which could be used in agriculture, and the government also is discouraging the people from using animal dung cakes. So why? Because most of our people are farmers and we can use this cow dung as a manure in our field and our production will increase. So instead of that we are simply burning it away for cooking and so on, then we are using or we are missing that valuable manure, the manure that we can have. So instead of you can reduce the fertilizers, chemical fertilizers, and use this cow dung for cultivation, and we will be getting healthy food. So government is discouraging both the use of firewood as well as the animal dung, which can be used for some other purpose. So we shall stop today again, and the next day we shall study about in detail about these two type of energies, conventional source as well as non-conventional source of energy. So thank you, have a nice day.